Identify the system and its constraints. The problem states that the iron, Fe, and water are mixed inside a perfectly insulated container. In thermodynamics, a perfectly insulated container represents a closed, adiabatic system where no heat can be exchanged with the outside surroundings. Apply the first law of thermodynamics. Conservation of energy. According to the law of conservation of energy, energy cannot be created or destroyed, only transferred. Therefore, inside this insulated calorimeter, any thermal energy, heat, Q, released by the cooling system must be completely and exclusively absorbed by the warming system. Q lost equals Q gained. Determine the direction of heat flow. Since the iron sample is initially at a higher temperature, 100 degrees Celsius, than the water, 35 degrees Celsius, thermal energy will spontaneously transfer from the hot iron to the colder water until they reach thermal equilibrium. Relate the heat quantities. Because no thermal energy escapes the insulated container, the total magnitude of heat energy lost by the cooling iron must be exactly equal to the magnitude of heat energy gained by the warming water. This directly identifies option D as the true statement. The correct answer is option D. The heat energy lost by the Fe will be equal to the heat energy gained by the water.